Hey Izzy, how are you today?
Good, how are you?
I'm well.
So what are we working on today? There's
Well,
a lot of interesting equipment.
Yeah. Well, today I want to go over the Asphalt T304, which is the uncompacted void content of fine aggregate, or the FAA.
Like airplanes?
No, not that FAA. This is the
Okay.
fine aggregate angularity.
So I've been reading about the aggregate angularity within asphalt mixtures,
Yeah.
but why is the angularity so important?
Oh, great question. So the aggregate angularity is important because the more angular aggregates lock up together better than the rounded particles, and it gives us more stability to resist things like rutting or shoving in our asphalt pavements.
Cool, that makes sense.
Yeah, so the Asphalt T304 uncompacted void content of fine aggregate, or FAA, we're going to use method A today.
Okay, method A. How many methods are there?
Oh, there's three methods. So there's an A, a B, and a C. And the difference really is just how the specimen's prepared before you run it through the apparatus. So the things that we're going to need today to go through this process, we're going to need a balance. We're going to need this funnel that's in a frame like this, a calibrated cylinder here. We're going to need a spatula, a brush, and this pan.
And this fine aggregate.
Yeah, and the fine aggregate, of course. So let's start out by getting a tare weight of our cylinder. So I'm
Okay.
going to set that on the balance. Let me tare it out first. So it looks to me like we have a tare weight of 186.1 grams.
Okay,
So write that down.
got it.
Okay. So next I'm going to place it in the frame here, and we're going to pour this sample in there.
And why is it so dry?
Oh, great question. So with method A, when we go to prepare this sample here, we're going to take and we're going to wash the sample over a 200 sieve, put it in the oven to dry it.
Dry as a bone.
Dry as a bone. And then we're going to go ahead and separate it out across 4 different sieves.
Okay.
So we're going to have 44 grams from the number 16 sieve, 57 grams from the number 30 sieve, we're going to have 72 grams from the number 50 sieve, and 17 grams from the 100 sieve. All totals up to be 190 grams.
Sounds pretty precise.
Yeah, it is, but we need that so that our results are reliable.
Okay.
So, next thing we're going to do is we're going to dump the aggregate into the funnel here, but we don't want it to flow directly in.
Okay.
So I want you to put your finger on the bottom there and hold it so that it doesn't flow out until we're ready.
Okay. That kind of reminds me of when, I would help my dad with projects in the garage. He'd be like, hold this still.
Oh, yeah, but this won't take very long.
Okay,
Okay?
good.
All right. So I'm going to pour the aggregate in. I'm going to use the spatula to make sure it's level across the top here. And then when I tell you we're going to release it, it's going to free flow into the cylinder there in an uncompacted way, which is going to represent the natural packing we would see in the aggregate.
Okay, cool. Count me down.
Okay, here we go. 100, 99, 98.
Why don't we start from 3?
Okay, 3 works, 3. Okay, 3, 2, 1, release.
That's all the aggregate.
Yep, that's all of it. So the next thing we're going to do is we're going to strike off the top of the cylinder. We're going to use the spatula, and keep it very vertical here, and we're going to do one quick strike across the top.
Cool.
It's really important that we do it that way so that we have the exact volume that's in that cylinder.
Okay.
So next, I want you to take the spatula and just tap the edge of the cylinder just a little bit, and that's going to allow the aggregate to drop down in so we don't spill it when we move it to the balance.
Is that good?
Yeah, perfect,
Okay.
perfect. Next, I'm going to use the brush. We're going to wipe off that aggregate that's around the rim on our cylinder here so it doesn't mess up our weights. And we can take our cylinder, put it on the balance. Let's see, so the cylinder and the aggregate together weighs 337.7 grams.
Awesome. All right.
So, to get the weight of the aggregate, we just take the weight of the aggregate and the cylinder together and subtract off the weight of the cylinder.
Okay, so 337.7 grams minus 186.1 grams. And that gives me 151.6 grams.
Yeah.
Awesome.
Yeah, that sounds about right. That
Yeah.
sounds about right. The next thing that we're going to need is we're going to need the volume of the cylinder. So this one here has been calibrated. It's 100.2 cubic centimeters.
Okay.
And we need the specific gravity of the aggregate. And this aggregate happens to be 2.650.
Okay.
So next, in order to calculate the uncompacted voids, we're going to use the formula. Uncompacted voids is equal to the volume of the cylinder. We're going to subtract from that the weight of the aggregate divided by its specific gravity. Divide all of that by the volume of the cylinder again, multiply by 100 to make it a percentage.
Okay, so 100.2 minus, in parentheses, 151.6 divided by 2.650 all over 100.2 and then multiply all of that by 100.
Yeah.
So I get 48.09%.
Yeah, well, but we present this as the nearest tenth.
Okay.
So let's go with 48.1.
Okay, so the uncompacted voids percentage of this sample is 48.1. That's above the 45% specified.
Yeah, yeah. And a lot of agencies use that 45 number. So the more angular the aggregate is, the better it is for our purposes.
Okay, so what's next?
Well, next, method A says we're going to take this exact same specimen, we're going to run it through the apparatus again, do the test again, and then we're going to average the two numbers together, and that's what we'll report.
Okay, can I do this one by myself?
Sure.
Okay.
Hey, thanks for watching. Hope you found something interesting. Don't forget, click that subscribe button down there, probably the like button too, and come back to see more training in your pocket.